An angle can be measured in degrees, but it can also be measured using radians. A radian is defined to be the measure of an angle that is calculated by the ratio of the arc length divided by the radius of the circle. So here we have an angle, let's call it theta. The radius of our circle is r, and the arc length measurement is this value s out here. So the measure of this angle theta is approximately 1 because when we look at the ratio s divided by r, or arc length divided by radius, when these two values are the same, then that ratio reduces down to being 1. So I've attempted to draw something where the length of this radius and the length of the arc are the same. So let's say that we had a circle of radius 2 and we sweep out an arc that is that same distance of 2. The angle that we would sweep through in order to achieve this arc, measured in radians, would be the length of the arc divided by the length of the radius, which is 1. So 1 radian is the angle that we must sweep through to achieve an arc length that is the same length as the radius. So again, let's state here that we get 1 radian when the arc length is equal to the radius. Let's also notice that radians as the measure of an angle do not use units. And this is because we use the same units to measure the radius as we do to measure the arc length. So in this scenario, we're looking at an arc length of 3 inches and a radius of 5 inches. So the units would cancel and we would end up with an angle that is measured using radians, but we don't write the units radians. We would say if we're measuring an angle in radians, we would not put units on it. The arc length formula is used to calculate the length of the arc that is swept out when we move through an angle on some given circle. And this arc length formula comes directly from the definition of an angle measured in radians. An angle measured in radians is defined to be the length of the arc divided by the length of the radius. If we take this equation and multiply both sides by r, the r's cancel out on the right, and we end up with theta times r is equal to s. So switch that around here and we have what we are referring to as our arc length formula. So let's use this formula to complete this first example. Find the length of the arc on a circle of radius 10 meters subtended by a central angle of 1/2 radian. Let's look at a quick concept drawing. Here we have a circle of radius 10 meters, and we're going to sweep out an angle of 1/2 radian. We're being asked to find what the length of this arc is. So we'll use the arc length formula, which is s is equal to r times theta, but let's make a note that this formula only works when our angle theta is measured in radians. And that's because this formula came from the definition of an angle measured in radians. So our arc length is going to be, the measure of our radius is 10 meters. The measure of our angle is 1/2 radians, but remember, radians do not carry units. So the units of our arc length are just going to be meters, because meters times no units will stay just meters. So we have 10 times 1/2, which is 5, and the arc length is going to be 5 meters.